This illustration deals with fault current available in accordance with NFPA 70E, Article 100, Informational Note 3. The purpose of change was to provide a new informational note that would inform the user of NFPA 70E that a ground fault could occur anywhere on the electrical system. For example, it could appear here in this equipment here. Anywhere along the conduit run with the conductors it could appear, or it could happen in here. Maybe even it could occur here, somewhere in the run of conduit and conductors back to the transformer. Now, for example, if this transformer delivered 1,000 amps of usable current under normal operating conditions, and you had an impedance of 2%, 2% into 1,000, 50,000 amps would be right here if a ground fault occurred right in here. Now, the only thing that would lower that current would be wherever it appeared in this system, and the length of the conductors and the size of the conductors and so forth between the fault and the transformer. And for example, you say, well, 50,000 amps is a little high here. I'll just increase the 2% impedance to 4%. Now I just reduced it to 25,000 amps that would occur here. So the length of these conductors, size of these conductors, copper, aluminum, whatever they may be, will determine what the available short circuit current would be here. What is noted here, it would be different if it happened here than if it happened here. And it could even be a little different if it should happen here. If it occurred here, then naturally it's going to be much lower. So we sized this grounded conductor here back to this transformer in size for ground fault conditions based upon the size of these conductors. So as you know, as an example, if 4-volt conductors terminated to a 225 amp main, the minimum size of this grounded conductor here from our table 250.102C1 in the NEC would be a number 2. But however, it may be required to be larger if there was a neutral involved by 220.61 of the NEC. And naturally, the larger of the two would be selected. Now, NFPA 70B kind of gives a warning to electrician. When you remove the cover here, or just open up the cover, and you review the circuit mapping, if there were more phase-to-phase loads than neutral loads, then this conductor may be just sized from table 250.102, C as in car, 1. But if the circuit mapping directory showed that there were more neutral loads than phase-to-phase loads, then the calculation of 220.61 may require this conductor to be much larger. So those are little tips that we pick up as electricians when we work on equipment and want to know what the available short circuit current may be at any given point where we're working in the electrical system. So that's what this definition is all about, is defining fault current that's available to an area where we may be working. Now, we know a L1 to L2 ungrounded phase conductors could be a short circuit and create a problem. We know then L1 to ground, to the equipment ground, or to the metal enclosure that is grounded and connected to earth ground in some manner would be a ground fault. So the code for the first time is defining what a short circuit is and what a ground fault is. So review your definition very carefully. there around page 12 of the 70E document, and I believe that you will be enlightened of what this informational note and definition is trying to get over to you and I. Now, notice in the note here, it states a short circuit can occur during abnormal conditions such as a fault between conductors or a ground fault. And again, on page 12 is the new informational note that you can review to get a better handle on what 70E is requiring here.